Have you ever wondered why we can't see dinosaurs roaming around today just as they did millions of years ago? Dinosaurs, these colossal creatures that once dominated our planet, were a diverse group of reptiles. They came in all shapes and sizes, from the towering T-Rex to the tiny Compsognathus, each with their unique characteristics and roles within their ecosystems. The reign of dinosaurs on Earth is an era we refer to as the Mesozoic, a period that spanned over 180 million years. This era is further divided into three periods: the Triassic, Jurassic, and Cretaceous. Each period witnessed the evolution of different dinosaur species, making the Mesozoic a veritable carnival of these fascinating creatures. The world was their playground, and they were the undisputed rulers, so powerful and so diverse, yet they vanished, leaving us with nothing but their fossilized remains to ponder upon. So we know that dinosaurs ruled the Earth for millions of years, but what happened to them? The question of what happened to the dinosaurs puzzles scientists and enthusiasts alike. Let's delve into the theories behind their extinction. The first theory that often comes to mind is the asteroid impact theory. This theory postulates that a massive asteroid or comet, around 6 to 9 miles wide, struck the Earth some 66 million years ago near what is now the Yucatan Peninsula in Mexico. The impact would have caused a massive explosion, releasing energy equivalent to billions of atomic bombs. This would have triggered a chain of catastrophic events, including wildfires, tsunamis, and a nuclear winter effect, where dust and debris blocked out the sun, causing a drastic drop in temperature. Then we have the volcanic activity theory. Around the same time as the suspected asteroid impact, there was intense volcanic activity on the other side of the globe in what is now India. These volcanic eruptions, known as the Deccan Traps, spewed out vast quantities of lava. But more importantly, they released toxic gases and particles into the atmosphere. This could have led to a series of environmental changes, including acid rain and global warming, conditions not conducive for the survival of these massive reptiles. Lastly, there's the climate change theory. This theory suggests that long-term shifts in climate and sea levels could have played a role in the dinosaurs' extinction. As the Earth's climate changed, habitats would have shifted, food sources could have dwindled, and competition for resources would have intensified. This gradual change may have led to a slow but steady decline in dinosaur populations. These theories, while widely accepted, still leave room for debate and further investigation. Each theory has its strengths and weaknesses, and it's entirely possible that a combination of these events rather than a single one was responsible for the end of the dinosaurs. Unraveling this mystery continues to challenge and fascinate us, reminding us of the dynamic and often unpredictable nature of our planet. The asteroid theory, also known as the Alvarez hypothesis, is the most popular explanation for the dinosaurs' extinction. But what evidence supports it? Let's dive into it. Picture an asteroid, a colossal chunk of space rock, hurtling through the cosmos at unimaginable speeds. This is no small boulder. We're talking about something roughly 6 miles in diameter. Now imagine it slamming into Earth with a force billions of times stronger than the most potent nuclear bomb. That's the crux of the Alvarez hypothesis. The father-son duo, Luis and Walter Alvarez, first proposed this theory in the late 20th century. They suggested that about 65 million years ago, such an asteroid impact occurred, leading to a catastrophic sequence of events that wiped out the dinosaurs. One of the most compelling pieces of evidence for this theory is the discovery of the Chicxulub crater in Yucatan, Mexico. This massive crater, over 120 miles in diameter and 12 miles deep, is believed to be the impact site of the fatal asteroid. The size and age of this crater align perfectly with the Alvarez hypothesis, but the crater isn't the only evidence. A thin layer of iridium-rich clay, known as the KT boundary, has been found in geological strata worldwide. Iridium is rare on Earth's surface, but it's abundant in asteroids. This global layer of iridium, dating back to the same time as the Chicxulub impact, suggests a vast cloud of dust and debris was thrown into the atmosphere following the asteroid's impact, blocking sunlight and leading to a nuclear winter. This would have caused a drastic drop in temperature, devastating for the dinosaurs. In essence, the Alvarez hypothesis paints a chilling picture, a world plunged into darkness and cold where food becomes scarce and the mighty dinosaurs meet their doom. The asteroid theory, though compelling, isn't the only explanation scientists have proposed. But for now, it remains the most widely accepted theory for the disappearance of these magnificent creatures from our planet. Another theory points to massive volcanic eruptions and subsequent climate change as the culprits for the dinosaurs' demise. Picture this. In what is now known as the Deccan Traps in India, a series of volcanic eruptions occurred over a span of hundreds of thousands of years. These weren't just any eruptions, though. They were cataclysmic events on a scale that's hard for us to comprehend, with each one spewing out enough lava to cover an area the size of Texas. Now imagine the impact of these eruptions on the planet's climate. The sheer volume of volcanic material released into the atmosphere would have had a profound effect. Dust and ash would have blocked out the sun, causing temperatures to plummet in a nuclear winter scenario. At the same time, the release of sulfur and other gases would have led to acid rain, further devastating the environment. But that's not all. The eruptions would have also released vast quantities of carbon dioxide, a potent greenhouse gas. Once the dust and ash settled, this could have triggered a rapid warming of the planet, a runaway greenhouse effect. The result? A roller coaster of extreme climate changes from freezing cold to scorching heat in a relatively short span of geological time. This theory is supported by geological evidence. Layers of rock in the Deccan Traps show signs of multiple massive eruptions around the time the dinosaurs went extinct. Moreover, studies of marine sediments from this period reveal changes in temperature and acidity consistent with the climate effects we've just discussed. So what does all this mean for our dinosaur friends? Well, the rapid and extreme changes in climate would have been very hard for them to adapt to. Food sources would have disappeared, habitats would have been destroyed, and survival would have become increasingly difficult. Whether it was an asteroid or volcanoes, the result was a drastically changed world, one that the dinosaurs could not survive. So, what happened after the dinosaurs disappeared, and what does this mean for us today? In the wake of these giant reptiles' departure, the world did not remain vacant for long. Earth's stage was soon taken over by a different class of creatures, the mammals. These animals, which had been relatively small and insignificant during the reign of the dinosaurs, suddenly found themselves in a world abundant with opportunities. The food chain was theirs for the taking, and take they did. Over the course of millions of years, mammals evolved to fill the ecological niches left empty by the dinosaurs. They grew in size and complexity, diversifying into countless species, each adapting to the unique challenges of their environment. This explosion of mammalian life ultimately paved the way for the evolution of primates and later the appearance of the first humans. So where do we stand today in our understanding of dinosaur extinction? We've touched upon the main theories, the asteroid impact and the volcanic activity, each supported by its own compelling set of evidence. The asteroid theory, bolstered by the discovery of an impact crater off the coast of Mexico and a layer of iridium-rich dust worldwide, suggests a sudden catastrophic event. On the other hand, the volcanic activity theory, backed by signs of massive lava flows in India, points towards a more prolonged period of climatic turmoil. Yet, it's important to remember that these theories are not mutually exclusive. It's entirely plausible that a combination of these events led to the end of the dinosaurs. Perhaps an asteroid impact triggered volcanic eruptions, or maybe the climate was already changing due to volcanic activity when an asteroid struck, dealing the final blow. Despite the wealth of knowledge we've gained, there's still much we don't know. The question of why some species survived while others perished remains a mystery. And the exact timeline of events, whether the asteroid impact and volcanic activity occurred concurrently or sequentially, is still under debate. The extinction of the dinosaurs, then, remains a puzzle with pieces yet to be found. The scientific community continues to explore these questions, driven by a desire to understand our planet's past. New discoveries are made every year, each adding another piece to the puzzle, each bringing us one step closer to unraveling the mystery. So what does this mean for us today? Well, the extinction of the dinosaurs is a stark reminder of the fragility of life. It underscores the importance of understanding our planet and its history, and it challenges us to consider our place in the grand scheme of things. The extinction of the dinosaurs, while a mystery, offers us a fascinating glimpse into the history of life on Earth. As we continue to explore and understand, we can only wonder, what will the future hold for us?
Subscribe for more videos like this. Turn on notification and leave a like to help the channel out. Thank you for watching.